Okay. So the first thing we're going to go over is what it means or what the rules are to multiply two square roots together. Right here is the official rule. And the official rule says basically that if you have two real numbers, a and b, the square root of a times the square root of b is equal to the square root of a times b. All right, and so it basically means that the multiplication sort of stretches underneath the square root signs. So for example, if we want to use this rule to multiply the square root of 5 and the square root of 7, we can say, well, this is actually equal to the square root of 5 times 7, which is equal to the square root of 35. This one here, the square root of 6 times the square root of 6, well, that's actually equal to the square root of 6 times 6, which is 6 squared. So that is just equal to plain old 6. We can do this with fractions the same way. You just multiply through. So the square root of 2/3 times the square root of 7/5 is equal to the square root of 2/3 times 7/5. Multiply straight across the top, and we get 14. Multiply straight across the bottom, we get 15. All right. Any questions so far? No? Okay. It's the same rule when we have the variables under there. Right? The square root of 2x times the square root of 3y, that's equal to the square root of all that stuff. So 2 times 3, that's 6. X times y, yx, or xy. All right, so that's the basic rule with multiplication.
It can be either way, multiplication, what you said, yx or xy.
Yeah, totally, yeah, and that's always the case. You know, this could be written as 6yx, 6xy, or you could even, if you were a weirdo, you could even write it as x, 6y. You know, why would you? I don't know, but I'm not going to take points off. Who cares? Yeah, and that's always the case. All right, so how do we simplify these things? Well, when we're simplifying these, we think about the reverse of what we just did, right? And so what we just did was when you multiply two square roots, you get a single square root. Well, the same is true is if you if you factor two things under a square root, you can split that up into two separate square roots. And that's it. That's what it means to factor a square root. You just split those up. So you can see this example here. I take the square root of 50. I break it up into its prime factors. 5 times 5 equals 25, times 2, that would equal 50. Then I separate those two into its squares, right? There's two factors of 5, and there's only one factor of 2. So then I could split that up into two different radicals. The square root of 5 squared multiplied by the square root of 2. The square root of 5 squared simplifies to just 5, and that gives me 5 times square root of 2. The same thing could be done with 48. You can see here in the first step, I just split 48 up into its prime factorization. Then I basically take anything that's in pairs in that prime factorization, and I can simplify that. Just like in the 50, I had a pair of 5s, right? And so I could simplify that. Well, in the 48, I have a pair of 2's here, and I have a pair of 2's here. So I can rewrite those as squares. And then I can split each into its own radical. And so the square root of 2 squared is just 2. As I've written here, square root of 2 squared is just 2. Square root of 3 can't be simplified anymore. 2 times 2 equals 4, so the whole thing is 4 times the root of 3. So the official definition of what it means to be simplified in a square root, it means that the radical expression for a square root is simplified when its radicand has no factor other than 1 that is a perfect square. All right, and so as you can see, like in this section of the root 48 example, I had 2 factors that were underneath there, 2 parts of the radicand that were perfect squares. So that wasn't simplified yet. I pop those guys out in this last step to have 4, and all I have is 3 underneath the radical, and that's not a perfect square, so I'm done. All right, let's do some examples. Suppose they ask us to simplify by factoring, and also let's go ahead and assume that all these variables represent non-negative numbers. So this first one, 18. 18 split into its factorized form is 3 times 3 times 2. I have a pair of 3's here. So I'm going to go ahead and arrange those. So now I have the square root of 3 squared times 2. All right, I'm going to go ahead and break these two factors up. So now I have the square root of 3 squared multiplied by the square root of 2. Square root of 3 squared, well, that's just equal to 3. So I have 3 roots 2. Any questions on these? Okay. All right. It's almost easier when we do this with variables because they're already split up into their factored form, right? We can see right off the bat that we can just write this as a squared times b. So I'm going to split these two factors up. Square root of a squared times the square root of b. Square root of a squared, that's just a. Square root of b, we just leave that. And that's it, right? And remember, we don't need to say absolute value of a because we assumed that all variables were non-negative. That's why we don't need to do anything too confusing in there. All right, so let's try this next one. 196t squared u. I don't know, maybe there's a square root of 196, I'm not sure. Let's hope there is, so I don't have to do more work. There is. So the square root of 196 is 14. We're just going to write that up here. Okay, so we're going to rewrite this in pairs. So I have 196, which is 14 squared. And then I have t squared. And then I have u, which is not a square. So I'm going to separate all these guys out, give them their own radicals. Split it up into the square root of 14 squared times the square root of t squared times the square root of u. All right, in the next step, remember the square root of some number squared is just that number. So square root of 14 squared, that's just 14. Square root of t squared, that's just t. And the square root of u, there's nothing else to do with that, so we just write square root of u. So remember, a common mistake is to accidentally pull out the full like t squared in this example. Just remember that only the t comes out, not the t squared. It's really common for me to see like, you know, people split it up like this, but then for whatever reason a little square pops up over here. You know, watch out for that because that's a really common mistake. All right, how about this crazy looking mess of stuff over here? This one's actually a piece of cake. So all we need to notice, right, we need to just go through and say, okay, which of these are 2 and which of these are only 1 factor? There's only 1 factor of A, only 1 factor of D, and that's it. All the other variables have 2 factors. So I'm just going to rewrite this. So I'm going to write B squared, C squared, E squared, F squared, and then A and D will go on the end. Now I split these guys all up. And could probably skip this step, but I'm not going to because we have plenty of time. So there we go. Split these guys up and give each square its own radical. Now when I write that, everything goes away except for the variables. So we have B, C, E, F times the square root of A times D. All right, so Now, let's real quick, they kind of just throw these ones in there at random. You'll probably run into at least one of these in your homework. It's an evaluation problem with the square root. Just like with every other evaluation problem we do, all this is a plug and play. So we have the square root of b squared minus 4ac, where a is equal to 3, b is equal to 6, c is equal to -5. So I'm just going to, plug everything in here. So I have the square root of b squared, which is 6 squared, minus 4 times a is equal to 3, and then times c, which is equal to -5. All right, what's that equal to? So I'm just going to break this down one term at a time. So I have my 6 squared here. That is 36. -4 times 3 is equal to 12. Actually, I should just do 4 times 3 times 5. That's equal to 60. Since we have two negatives that we're dealing with, this one and this one, that is a positive 60. So it's 36 plus 60. That is equal to 96. So now we just got to simplify that square root. I don't know if 96 has a square root. I don't think it does. No, it does not. But 96 does factor into 16 and 6. So I'm just going to continue this guy. 96 is equal to 16 times 6. And I just came up with that by guessing and checking real quick. There's no magic to that. I just said, I don't know. Let's try 16, and it worked. So, okay, so 16 and 6. So I'm going to rewrite this as 4 squared times 6. I'm going to split up my radical. Square root of 4 squared times the square root of 6. And I get 4 times root 6. All right, so yeah, when you get application problems on this chapter, I think they all just follow this basic method. It's just plug it in, simplify it. All right, let's try some different stuff. So as we saw in the last examples, taking the square root of an even power, you arrange things in a certain way, right? When it's even, you know you're not going to have a root left, basically, right? Because when we have even powers, we know we can always arrange them in pairs. And so when we take a square root of an even power, we're really just dividing the power by 2, because we can rewrite it as so. So x to the 4th, we can rewrite this as x squared times x squared. We can rewrite this as x squared in parentheses squared. Does that make sense what I just did there? Okay. So now I have the square root of x squared squared. And when this happens, remember, we just take this value and pop it out. So this guy is equal to x squared, right? Just like the square root of a squared is equal to a. If x squared takes the place of a right here, then x squared pops out on this other side. Okay, so we can rewrite this guy, y to the 10th. This can be written as y squared times y squared times squared times y squared times y squared. We can rearrange these guys. Let's see now. Yeah, so I can rearrange this as y to the 5th squared. Sorry, I should have actually broken that down in a different way. That's a little bit weird the way I did that. But you can see why it breaks down in that way. You know, I guess the better way to break it down would have been like this. I should have broken it down like y to the 5th times y to the 5th. There we go. And that equals y to the 5th squared. But anyway, once again, the square root of something squared is equal to that something. So this is just equal to y to the 5th. All right, k to the 66th. Well, we can rewrite this as k to the 33rd squared. I'm not going to do that one in long form because it would take me too long. And once again, we have something, the square root of something squared, that something just pops out the other side. So we have k to the 33. Does that make sense? Okay. That's a little bit weird sometimes. And more or less, like, you know, if you have an even number up here, like to simplify the square root of something that has an even power, you just cut that power in half, you know, and so you can see here y to the 10th ended up as y to the 5th. K to the 66th ended up as k to the 33rd. X to the 4th ended up as x to the square, x squared. So it's, you just cut them in half. Now, sometimes we're asked to take the square root of an odd power. When we do that, we just rewrite it as an even times a single power and then move forward. So x to the 3rd, well, that's equal to x squared times a single x, which is equal to the square root of x squared times the square root of x, which is equal to x roots x. Okay, if I had x to the 5th, that is just equal to the square root of x to the 4th times a single x. If we split this guy up, we can rewrite it as x squared squared times root x. The x squared pops out, and we still have the root x. And I mean, you know, if you do enough of these, like there's going to be a really obvious pattern. You probably see it already, right? It's whatever this first number is. If it's odd, that number, you subtract 1, divide by 2. That's going to be the exponent out here in front. And you're just going to have a single variable under the radical. Okay, so if we keep playing this game with the odd numbers, we see that once again, we can rewrite this as x to the 6th times x plain old x, and then when we split up our square roots, we get the root of x to the 6th times the root of x, and the root of x to the 6th is just equal to x cubed, and that is times the root of x. Okay, I skipped a step in here. There is a step in between these two. Maybe I'll just write it up here. All right, so how about this one? T to the 15, what's that going to be? Almost. T14 times what? T? Square root of t. Yeah. T14 times root t. Oh shoot. T14. What am I? I wasn't thinking there. T7. Sorry. I wanted that to work so bad. All right. Right. Okay. So and why is that true? Well, because t to the 15. Root t to the 15 can be split up into t to the 14 times t, which is equal to t to the 7th squared times root t. That's why that works out.
Those following the example is root x7 where you have root x6 times tx.
Oh yeah, but you got to follow it all the way to the end, right?
Or if you're going to do the
All right. So there's that. So there's evens. Remember, evens, you just split them off into pairs and rewrite it like that. For odds, you just split off the odd factor and then proceed to simplify the even power. All right. Let's do some examples here. How about t to the 22nd? What's that going to equal? Too far. T to the 11th. That's it. Right? When it's an even number, you split it in half. That's it. When it's an odd number, then it's a little different. All right, so how about this one? What about x to the 9th?
X to the third times.
Not x to the 3rd. It's sort of, yeah, that's what you're going to start splitting it off into, right? It's going to be x to the 8th times x, right? And then we're going to split those two apart. And we're going to rewrite x to the 8th as x to the 4th squared times root x. And that is equal to x to the 4th times root x. Remember, if we got an odd number here, we subtract 1 and then divide by 2, and that is what our little exponent will be out here. All right, and so here's a fun one. How about you guys do this one on your own? And go ahead, like, you know, it might help to compartmentalize this stuff, you know? Write it as a, you know, radical 32 times radical x to the 11th times radical t to the 6th. All right. So for this guy, I like to take these guys just kind of one section at a time. So the first thing I'm going to do is just split these guys up into the groups that I'm sort of going to separate them into. So 32 splits up into 16 and 2. I chose 16 and 2 because I know that 16 is a perfect square, and that's going to simplify later. So x to the 11th, that splits up into x to the 10th times x. And then t to the 6th, I can immediately rewrite that as t to the 3rd squared. All right, so in my next line, I'm going to go ahead and split up these radicals even a little further. And I'm going to say 16, that equals the radical of 4 squared times root 2. X to the 10th, that's going to split up into x to the 5th squared times plain old x. And then I have times t cubed, square root of t cubed squared. Well, I'm just going to go ahead and simplify this right now because there's nothing else to do with those t's. The t cubed pops out. All right. So now I'm going to go ahead and rewrite all these factors out front, these guys that can simplify. So the square root of 4 squared, that's just equal to 4. The square root of x to the 5th squared, that's just equal to x to the 5th. And t cubed, that's pretty clear what that equals. So those three are gone. And then I just write what I have left, which is the square root of 2 times x. All right. So that's that. Really is just a matter of sort of breaking it all up, splitting it out into what will simplify and leaving what won't simplify behind. All right. How do we multiply radicals? Oh, I think we already went through this. Oh, okay. So recall that when we multiply radicals, they just multiply straight into each other. And so 2 radicals multiplied together, 2 square roots, is equal to a single square root. So sometimes you can do the multiplication first and then simplify afterwards where you couldn't have done that in the first place. So we have 2 times root 2 times root 14. Well, that's equal to root 28, which is equal to, what is that? 28 divided by maybe 4? Yeah, which is 4 times 7. 4 is a perfect square, so I know I want to use that one. And this is equal to the square root of 4 times the square root of 7. The square root of 4 is just 2. So we have 2 roots 7. We do the same thing here. We have 5t times, the root of 5t times the root of 6t. Well, that's just equal to the root of 5 times 6 times t squared, which is equal to the root of 30 t squared. I know I can pull the t squared out at least. I don't know, can I simplify 30 at all? 3 times 10, that splits up. Let's check. Let's make sure. So to make sure that I can't simplify 30 anymore, I'm just going to create a factor tree. Right, 30 splits up into 15 times 2. The 2 drops straight down. The 15 splits up into 3 and 5. So I look at these. There are no pairs, so I can't simplify that. So I'm just going to leave 30 in the radical. So what I do notice, though, is I have t squared, so I can pop that one out. So I rewrite this as the square root of t squared times the square root of 30, and we just get t times root 30. T roots 30. Okay, let's keep going. When we just have variables, those are just multiplied together. So I have square root of n squared times the square root of n cubed. That's equal to the square root of n to the 5th, which is equal to the square root of n to the 4th times n. That's equal to square root of, n square root of n squared times root n, which gives us n squared root n. All right. So now we can keep playing this guy, keep playing this game. So now we have, let's see now, 2 times 9. I'm just going to multiply all these together. 2 times 9 is 18. X to the 8th times x cubed, that is x to the 11th. If I rewrite this guy, I can rewrite it as the root of 3 squared times 2, the root of 2, right? That makes up for the 18. And then that's multiplied by x to the 5th squared times root x. Everybody see what I did there? Take your time, take a look at it. All right, so now I just go ahead and carry out my little square root simplification on those two, and that gives me 3 times x to the 5th. All right, so those two are gone, and that is multiplied by root 2x. All right, so keep that in mind. Sometimes things simplify further after you multiply them together. All right, so I have an activity for us today. It's very fun. Just kidding, it's not that fun. So we ended early again. Just go ahead and complete these problems, show me your answers, and then take off. That's your ticket to get out of here, is just completing these problems. Go ahead and talk together. You know, it's fine to chat with each other about the answers, compare notes. This up here, what I've written right here, this is an example of what I want to see. Give me this intermediate step. All right, got to have that. I don't just want to see straight from this to the answer. I want to see that intermediate step where you regrouped everything. And these are the problems. 1 through 9 over here, and then number 10 is just right here. And don't hesitate to come up, get some clarification, ask for help, anything like that. That's what we're here for. These are definitely a little bit tougher than what we just did in the lecture.
Calculator can borrow. You know, that's not a whole.
Oh, yeah. By the way, if you want to check your work on these, you can just calculate the beginning result and the end result. And so for this first one, you can punch in the square root of 24 in your calculator, and when you get to the answer, which should be 2 root 6, you can punch in 2 times root 6, and it should be the same answer. Not quite. And so what you want to do with 24, right? 24 splits up into 4 and 6.
Okay.
These work because 4 is a perfect square,
okay.
right? 12 isn't a perfect square, and neither is 2, and that's why that doesn't quite work. Okay?
All right.
Just realized I skipped 8. And don't worry about 9 either. That one's jumping the gun a little bit. That's next chapter. So you got a 2 squared. Yes. Yeah, exactly. Yeah. And so like this simplifies into just 5. This simplifies into just 2.
So do you multiply that?
Yes.
And then 10.
So it's 2 times 5 times root 2.
Right. So it would be. Oh, okay. So just 2 times 5 and 2, and then you don't multiply that.
Yeah, you do. Yeah, you do. You always multiply that
Okay,
out.
so
So
it'd
it's
be
10
10.
roots 2. Yeah.
Okay, but then you can still do the 10 though. Would that matter? Or 'cause-
How do you mean?
never mind. I'm just joking. I got it.
Okay.
I was overthinking.
Good. Not quite.
Guess we could take this one. Right, to take out another 2.
All right, aren't you? Did I do that one wrong? I think I did that one wrong. 72 is 9 times 8, right?
Yeah.
9 times 8. Oh, no, that's right. 8 is 3 times 2. Yeah, okay. So this is correct.
So,
Yeah.
so that's here.
Oh, okay.
And
So
then to
you can
take-
still break 8 down
So I
further.
can still,
Yeah,
and that's
it.
my question, is that
Gotcha.
do I break it down even more? So
Yep.
then it's 2, so then it comes out to 6 square root 2.
There you go, yeah.
And then, is this right? If the square root of x is x and the square root of c is c.
Got
so
it.
that one.
Perfect.
And then here, broke it down.
Mhm.
So it's 6x, because that's the 5th. And that, you break that down to y to the 2nd times y, and so you get
Yep.
y to y.
Excellent.
And then you break that down to 10 square 2.
Perfect.
Okay, so I'm doing all right?
Yep.
Not bad, I'm getting 5 minutes of class.
So what do we do? Sure, no, that's great.
So,
So I got this one broke down, but I don't know what to do with that one.
okay.
Because you can't really break it apart from what I can figure out.
You can, and this is one, just the other day I told somebody, I was like, what about 27? That's prime. It was not. 9 times 3.
Oh.
That's the weird one that
Yeah,
looks so prime, but it's actually not.
Okay.
And so, yeah, you split that up
So,
into
yeah,
9
it would be
times
9
3.
times 3. Oh.
Yeah.
Okay.
Once you get down, we break it down, right? Here, here. And we break this further down, right? To 3
Right.
to the 2nd. And this one's 2 to the 2.
Mhm.
And that's okay. And then we just move it over to here. And we get 3 here.
Mhm.
And 3 inside.
On 6 or 7. Oh, you're on 6. Okay.
So I got. And then.
Okay. So there shouldn't be a 6 out here, right? Because 6 times 6 is 36. And that's more than what we had in the first place, right? 27 breaks down into 9 and 3.
I got that.
And so a 3 should pop out, but that's it.
I know, but if you go further down, because that's.
Right, you
to
popped
the
a
P.
2 hour as a variable, huh?
To P.
Yeah, there you
Got it.
go.
Okay, that's where I'm.
How's it going, Ed?
At least I got examples to.
Yeah. Okay. All right. So this first one, right? 3 and 8 doesn't quite work because neither of these are perfect squares, right? But 4 and 6 does work because 4 is a perfect square, right? And so you want to split that up into 4 and 6. The square root of 4 is 2, so that's equal to 2/6. Does that make sense?
Yeah.
And with 72, like, you know, let's see now. 72, you got to kind of play the same game, right? And so 8 and 9, that works because 9 is a perfect square, right? What's the square root of 9?
3 and 3.
3, yeah.
3.
So this, 8, the square root of 8 times 9, this is equal to 3 times the square root of 8.
10 and 5.
Oh, okay.
But then you can break 8 down a little bit further.
Okay.
4 and
Anything else?
yeah. 4 times 10.
Yeah, just go do these first two first and then come back and do those last ones. Yeah, remember, split them up into something that contains a perfect square.
Yeah. Yeah. Is number 6 before you get broke down to
Would that be,
So remember what we want a 2 out here,
oh, is that
right?
what
And
we're
so it's whatever it is times 2. And so p to the 40 should be p to the 20 squared. Yeah,
like that, and then that pulls out
exactly. And then p to the 20 is what pops right out. Yep.
like that, and then that's the rest.
Perfecto.
KR, and there's no 10 there because
Right.
I was dumb and I pulled that down. Okay.
Yep. 3KR. Got it.
You're right.
So I'm confident I did pretty well, but 7 was the one that got me the most.
7.
So check my process on the 7. I'm not sure if I did 7.
Okay.
I should.
So let's see now. So what does it do?
So I broke it all.
Oh, I see. Okay.
Yeah.
So the best way to handle 7 is to combine the 6 and the 12 first, and then simplify that one number instead of simplifying 2 across the board, right? Because when you combine 6 and 12, you might have a different number that you can pull out, you know, and so you always want to combine all the constants. Because when you do combine 6 and 12, you actually get 72, which is something that we've already done. And so we already know that 72 breaks down into 6 roots 2. And so for this one, we can just pull a 6 out and leave a 2 in.
So
we already know it. And so it's like, yeah, it's a, you know, this is an okay way to do it, but you might miss things if you keep them separated like that.
So it's a lot easier just to combine, like multiply the.
It's easier, and you're more assured to get the simplest form. Like if you do it this way, you might not be able to find a perfect square in those separately where you could if they were together, which seems a little strange, but it does work out that way. And so yeah, always combine the full constant and then simplify the full constant.
So it's a lot easier just to multiply them together first.
Yeah, definitely, definitely.
Do you want this or?
Let's see now. Mix everything. Just make sure it's all good. 3KR. 6x, blah, blah, blah. So. Oh, except for this one. So you have x to the 10 here, and this is an even number, which means you should have no x underneath here. And so 10 can be written as x to the 5th squared.
So then this should be actually.
This should be x to the 5th out here. There should be no x under there. And this y should be a squared. And this is correct with the y.
Oh, I see. So
right?
only do that method if it's only even or odd.
Yeah.
Oh, okay.
Okay.
Awesome.
Yeah. Good job, though. Hello. All right. What we
I
got
underlined the
here?
answer, it's kind of hard to
Okay.
see.
Good. That's good. Okay. Oh, I see. I was like, wait, how did you get 3 roots 8 out of that? That's 2 though. Okay. So this one you can break down a little bit further because 8 is equal to 2 cubed. So there's that. Right here for 3 is that one. Okay. There we go. Okay.
I got
So
it backwards though.
we
Doesn't
can
matter.
pull. So one thing we should notice though is we have a c squared here. And what's the square root of c squared? C. And so that shouldn't be there. It should just be right out here. Okay. So 5. That one is in reverse.
Oh, my
Right?
god.
It's all
I'm getting
good.
it back.
This is why we do this, right? And so this is, root 2 times root 100, but the square root of 100 is 10, right? And so this, the 2 doesn't come out of the
Okay.
square root, so 10 roots 2. 6, we have 3k on 2p, 23k. Nice job on that one. 7.
That's, I think, the answer.
Oh, okay. Okay, good. This one, again, though, 2 to the third. So you could simplify that. This one's perfect. Nice job. You're set. Thank you. Okay.
It's a little messy.
It's all good. So what do we got here? We got 2 roots 6. We got 6 roots 2. X, X. Good, good, good. Number 4.
Oh, it's right.
Where is it? This one? Oh, okay. It's to the 5th. Good. Good. 6. Okay. 2p23kr. Good. 6ab. 2a.
Oh, what did I do wrong with the B?
No, let's see now. So we have, let's see now. Oh, okay. This should be b to the 5th right here.
Oh, okay. I wrote it down
And so
wrong.
you have a total of b to the 6th, and so there should be b cubed out here with no
Right, okay.
b.
Okay.
And so you're good. No need to come back up.
I have a question on this one,
And then there's
though.
that one.
Is that, I don't know if I did
Yeah,
that right.
that's the perfect way to do it. Yeah, exactly.
Perfect.
Nice job.
Yay.
All right.
So
6ab. Yeah. Good on that. Perfect. Yeah.
okay.
Nice. Right. So, C, good, good. 6 to the 5th, y. 10 roots 2, excellent. Yeah, absolutely. P20, nicely done. There should be a 3 in here though.
Oh.
That's it, and that's just because this 27 split into 9 and 3. We just missed 1 3. It's all good. Number 7, we had 6ab. Oh, okay. So let's see now. So this b should be a cube right here, and then there should be no b under here.
Oh, okay.
And we can see that because we start out with 5
Yeah.
here and 1 here, so we have a total of 6.
Yep.
Which means there's just a cube.
Okay.
But and then that one is excellent. You're good. Thanks a lot,
Thank you very
Nathan.
much.
How do you do the root on this
Oh.
one again?
Yeah, so you
I did
say, you go second, and that accesses all these little blue letters, and then square root, and then whatever number.
Okay.
Okay?
Cool, thank you.
Yeah.